On this week's episode of Make It with Calvin, I'm going to be taking you guys through the workflow process of how I made the custom Black Beetle side frames for my friend's little doodlebug steam locomotive project. So let's talk about it. So the backstory on this whole project is actually a little bit more complex than it seems. Over at Ardenwood's Railfest that I've posted up videos about, I was talking to one of the members of the California Central Coast ON30 group that I'm a part of, and he was saying, hey, I'd love to see how you make your parts in a design to finish product video. I'd love if you could maybe come down to one of the events and talk to our guys about it. And I'm like, I would love to do that. And I thought to myself, duh, I haven't really done any videos that go in depth into here's how I go about and do the parts. So on Labor Day when I was over at my friend Scott's house, you might remember him from some of the hilarious Yosemite short line layout workday videos. Scott's an awesome guy. He's been nice enough to hold on to my Moai for me in the process of moving and figuring out where I'm going to go and things like that. And I also need to crank out some custom engine parts for him. Well, I was over at his house over on Labor Day weekend, and I was asking him, hey, on your Steam Doodlebug project, what are you going to do for side frames? He's like, well, I was looking at this company and that company, but I don't know if anybody makes any Archbar truck side frames that are 31 millimeters axle to axle. And just half as a joke, I'm like, well, somebody who knows how to do 3D design has, a 3D printer living in their garage just standing right here. And he goes, wait, you can do that? I'm like, yeah, I can totally do that. Just get me an Archbar truck. I know the axle width and I'll kind of go off of that. So jump on over to Fusion 360, and the initial design I came up with is not perfect. It's a little too thick in the middle. I forgot a brace, but Scott was a cool camper about it. He was just like, you know what, no big deal. I can just throw the brace in there, and it might be a little bit thicker than what I wanted, but for a first batch, that'll work fine. So I went ahead, went into Fusion, and I took my time designing it up. In reality, I probably could have had the thing done in under half an hour, but I was just kind of sitting there listening to YouTube videos and kind of just muddling my way through it. I didn't really have a time crunch because I was waiting for the Moai to get done with some prints. So the amount of time that it took to design the parts is a little bit falsified. If I really wanted to get it done faster, I could have done it faster, but I was just like, yeah, I'll get it done when the Moai's done, that sort of thing. So when I got done designing the parts, which really wasn't that hard, I did go ahead and I designed it so that way the ears that are on the power truck could be located to the Archbar side frame so you knew everything was centered. A little pro tip there, if you can do that, it really helps when you go to assemble things, so do that if you can. So once the parts got done in Fusion 360, and because I designed in inches, I know Jimmy's going to chew me out in the comments for that, I still design in inches. Eventually I'm probably going to move to millimeters, but inches is what I was always trained in, so that's what I'm familiar with. I then import the model into Simplify 3D, or really any program that can auto scale and then help me quickly orient the parts. Now I know there's probably going to be people jumping in the comments below going, well, I angle my parts like this much and then I do this much. And you know what? That is great. Awesome. If it works for you, cool. In my opinion though, it's easier if I just, angle the part, say 30 to 45 degrees, and it's fine. These are small parts, the peel force is not that much, and they're just decorative pieces, so strength is not that big of an issue. So I just went into Simplify 3D, laid the part flat, and then angled it up about 45 degrees that way, so that the underside, the part that you're not going to see, is the part that gets all the supports. If it's not as perfect, well, who cares? Once I got the part scaled and oriented correctly in Simplify 3D, I then marched on over to XYZware. I have tried using Asura, which is Pia Poly's own support program, and it's definitely pretty good, but I haven't really done any prints in it yet, so I'm not 100% sure how it all works out. So I just stuck with XYZware, which is what I'm most familiar with, and I believe I did a medium support density with a small tip diameter. This is a small part, so I don't need massive tips leaving a bunch of scars on the part. If I was doing anything bigger, I would definitely have jumped up to the medium ones, because I have had prints fail because the peel force was more than the contact force of the supports, and it didn't work out so well. So then from there, I exported the file and took it into Cura for the Moai. I know this is a lot of steps, guys, but that's just the way it is with the Moai. And honestly, it's not a bad thing. You do have total control over the slicer settings. You can choose whatever support program. Some people, heck, they even make their own support. So it's totally up to you. Then imported the parts into the Cura for the Moai. I just sliced the parts at 0.1 millimeters. There was really no point in doing anything less than that, because as it was, doing 4 side frames was going to take about an hour and a half, hour and 45 minutes as it was. It's getting late in the day, and I just wanted to get the prints done, and quite honestly, for what they are, you might be able to see the layer lines, but by the time Scott slaps a layer of paint on there, nobody's ever going to know. So with that said, into the Moai the print went, and time lapse later, we have the finished parts. Well, almost have the finished parts. Got to remember, because these parts are coming out of a vat of liquid resin that is not cured, so it's still reactive and still kind of icky, nasty stuff, the prints then need to be transferred over to a washing station. Different people have different setups, and mine is still a prototype that I'm hopefully going to be releasing a video on in the future. ETA on that is unknown. I literally FDM printed my own wash tank. So literally I can take the tray, drop it in there, and just let the part sit for about 7 to 12 minutes. It all depends. One tip that I learned from Sean over at Tested, though, is to scrape off the excess resin that's sitting on the print tray before you wash any prints. He was doing that for the Formlabs, but it's really good advice in general, because that resin that's on there will contaminate your alcohol, which gets really expensive when you're starting to buy it in gallon quantities. There have literally been times where I have wondered if buying the cheapest vodka at the supermarket is cheaper than buying stinking rubbing alcohol, but you know, whatever on that. And I put the prints into the tank, let them sit for about 10 minutes or so, and pulled them out, and hey presto, they were clean. Now at this point I could come along and I could gently remove them from the print tray. It is normal for some supports to want to stick a little better than others in certain spots. It's just kind of a look at the draw thing. I think also the age of my vat plays a role in that as well. There's areas that are a little more cloudy than others, so I had to up the laser power 1 setting, but the prints turned out just fine, so it was no biggie. Then once I had the prints off the bed and I let the alcohol evaporate for about 10 minutes, I was able to march them on over to Scott's workbench and remove the supports from them. So I know that sounds like a lot of steps, guys, but that's just the honest truth of what it takes to do prints on the Moai, or really any resin printer. And I'm not saying that this is a bad thing. I mean, one thing to keep in mind when you're doing FDM printing for, say, something like this guy, this is just a prototype before I Moai it as well. But I mean, for this, it required extensive support material to be put on the model. So even with an FDM model, you still need to do supports. Now they're all different. Every method is different. There's no one size fits all perfect solution, but in this application, it was the perfect test bed to show you guys the workflow process. So to give a total time involved to do this, I mean, printing it took about an hour and a half, which is pretty much a non-negotiable time. By the time I took the prints out, washed them, dried them, desupported them, that was at least another 15 minutes, or up to about an hour and 45 minutes there. And we'll just say, for the sake of easy math here, that slicing it and prepping it, which really didn't take that long, we'll just say that was another 15 minutes. We'll just say the total time was about 2 hours to go from the file to the parts, and really the designing only would have taken like 15 or 20 minutes had I really just been like diligently working on it, but because I was kind of putzing around working on this project and other projects, which was not a bad thing. It was more or less just a spare time project. That took a little bit longer, but the whole point of this is more or less just to show you guys the workflow and how it was done. Now, the really cool part at the end of all of this was Scott's reaction when he got to see the prints. He knows what 3D printing can do. I've done some other 3D printed parts and he's consulted with me about it. He doesn't do any 3D design work. He'll model things in styrene and give me the master and I'll go in there and work my magic. But the cool thing was he had never seen it go from an idea to a file to in the printer to a physical product all in the course of a couple of hours, because all the other work that we had done had been over days and weeks and months. And when he finally had the parts, even though he had a few constructive criticisms about maybe modify this and extend that and do whatnot, but he was still blown away at how fast we were able to get something done. And honestly, it's a good example of showing how 3D printing in modeling or anything can be a very effective way to go from an idea to a finished product. So you guys have any questions about the MOI, resin 3D printing for model trains, anything like that, please comment down below and I will do my best to answer your questions. And I will see you here next time on Make It with Calvin.